Hello, my name is Adam Wright, and this is my demonstration video for Homework 4. First, I will go over getData.py. In this program, we take the data from Y Finance and put it in a CSV file. And from those CSV files, we read the data, the dates, and all the adjusted close prices. And we do that and turn it into a viable data frame for our next program called Assess Portfolio. And here, this is where we request the dates and the tickers that we use for of the all the things that we're going to do. So I'll go over the methods one by one. For plot and normalized data, we will take the portfolio prices and the SPY prices, and we will extract the prices into regular arrays. And from there, we will normalize them with the first viable value. And from there, we will plot it. So if we run this, we'll get a graph here. As you can see here, the portfolio graph is way different than the SPY graph, and we'll go over why in a second. For get full portfolio stats, pretty self-explanatory. We take the prices from portfolio and the market value, which we will refer to as the SPY values. We have the daily return and the sample for a year. And we won't be doing the optional statistics because they are optional, so we'll be skipping that. Um, First, we will calculate the daily returns and put them in arrays, and from there, we would use that to um, calculate the cumulative return. As you can see here, the average return. We use the daily returns in the average method from NumPy, and we do the same with SPY. For standard deviation, pretty straightforward. We take the daily return, we take the standard deviation. For sharp ratio, we take the mean of daily returns and multiply them by samples per year. And we take the mean and we combine that with the standard deviation right here. But for the standard deviation, we'll be multiplying it by the square roots of samples per year. And for the sharp ratio, we take the mean, subtract it from the daily return, and divide by the standard deviation. For beta, we get the covariance of daily returns and the market daily returns, which is SPY. For the variance, we get the variance of the market daily returns, and then we divide that covariance by the variance, and we get beta. For alpha, we get something called expected return. So we take the daily RF, add it to beta, and multiply it by average daily returns minus daily RF. For alpha, we take the average daily return and subtract it from the expected return. And of course, we return that all to another method, which we'll go over in a sec. For again, the portfolio value, it's pretty straightforward. We put these starting values in arrays so we can normalize all four prices. And we return that as one list of prices with dates. And we return that as a variable called final. In a set portfolio, we get the sum of portfolio prices for the end value, which will be important later. We take the portfolio stats, and we also calculate the daily return for portfolio and SPY, and we use those to calculate the correlation, which is which comes in the form of a decimal, which is also a percentage. And once we do all that, we plot it using plot normalized data, and then we print the results. We print the results of the prices, the portfolio value, and the stats. And as you can see here, that's all done down here with our pretty printing method. And yeah, that's about it. Thank you for watching.